Let's, as a class, consider this. Let's make believe you're a golf course superintendent somewhere in Arizona, like you see in this picture here. Maybe some of you like going to Arizona and playing golf. Maybe you just wanted to become a golf course superintendent. And then you realize that there's a water shortage. Go figure, it's Arizona. And the golf course that you're overseeing is going to switch to treated wastewater as an irrigation source. Well, you probably know something about treated wastewater. It might have some salts present in it, which oftentimes it does. So how, by using this treated wastewater for irrigation purposes, how is that going to affect irrigation management in a location like you see in this picture on this golf course? And what possible problems could this cause? You probably already know based on the previous videos. And how do you prevent them? And this is something that we'll talk about in some of the upcoming videos, especially the one after this video itself. So some general backgrounds to lead you in how to manage. So first of all, poor quality irrigation water is oftentimes the culprit, and poor quality irrigation water can lead or add salts to soils and lead to salt buildup. In fact, more often than not, this is how salts build up in our soils because of poor quality irrigation water. So proper management can prevent excessive salt buildup, but it may not stop salts from building up. In fact, oftentimes it does not, because the irrigation water itself is the culprit. And so what do we need to do? Oftentimes we need excess irrigation water to continuously leach salts out of the root zone. And if you need to leach salts out, that means you need to have good drainage. So how do you know if you have a problem with your irrigation water even before you start applying it to, say, that golf course in the previous scenario? Well, you need to assess the irrigation water. And so just like assessing soil conditions, you can assess water conditions. And there's several ways in which you can do this, but it's best to have a reliable laboratory do this for you. So you can take an irrigation water sample or samples and send them to actually a soil testing lab. And the analysis that they will perform is basically identical to the analysis that you would perform on soils. They basically go hand in hand in a testing facility. So you can have an assessment of the irrigation water for electrical conductivity, and there's a subscript IW for irrigation water, or you can have a lab measure total suspended solids or total soluble salts, that's TSS, or total dissolved salts. And you can find tables that tell you the level of hazard with these irrigation waters. Is it a salinity issue? For example, right? That's EC. You can measure the sodium adsorption ratio of the water, right? So the amount of sodium in the water relative to other cations. And oftentimes the other cations are calcium and magnesium. And between EC and SAR, you can determine, and pH, you can determine if the water is saline, is it sodic, or is it saline sodic? Now, the tables that you have seen for soils that are either saline sodic or saline sodic are not identical for waters, but they follow the same general schematic. And I'm not going to share that with you because this is a soil fertility class and you get the idea. Occasionally, labs will measure alkalinity, like the carbonate and bicarbonate concentrations in the water. And all this together will tell you something about the irrigation water quality or lack thereof. And so you can use this information. In fact, if it's easier, you have a lab tell you how to use this information properly to manage irrigation water on the golf course that you saw in the previous slide. So the next video, we'll talk about specifically how to manage irrigation waters to maintain a certain level of salinity or sodicity in a soil.